Hello everyone. Today I will be showing how to measure FCC Crystal Lattice, that is face-centered cubic crystal. The geometry is already loaded into the UI. It was created in GridPro using analytical surfaces, planes and ellipsoids. The goal is to mesh only one region of the geometry and use the post-processing tools to get the full grid. This is the region which I am going to mesh, and this would be the corresponding grid. The final goal is to generate a grid like this, which can be done using post-processing tool extcon. Let's start with the topology creation. Similar to corner groups, there are 9 surface groups, which helps in various surface related operations. Since the region of interest is limited to this, group those surfaces and make the others inactive for better visualization. The required surfaces are being grouped in S1. Once it is grouped, change the display mode from A to G. This switches off the surfaces which are not part of the surface group S1. Firstly, a box macro is being created around the surface group S1. Note that we need the blocks only for one half of the ellipsoid. Hence, splitting the blocks at the necessary locations and deleting the extra faces from the UI. Similarly, doing the same steps on the third direction also. Next, splitting the blocks to define the ellipsoids. Note that a black edge is passing through the ellipsoid. However, we don't need the grid inside the ellipsoid. So removing the extra edge which is passing through the surfaces. Now the basic wireframe structure is created. Next step is to create an O-grid structure around all the 4 ellipsoids. To do that, the corners which define the ellipsoids have to be grouped and wrapped. So grouping the corners which define the ellipsoids in separate groups, such as C1, C2, C3, and C4. Then wrapping each group with a ratio of 5%. The desired topology is created. Next step is to assign the corresponding faces to its surfaces. Let's start with the ellipsoids, making an ellipsoid as current surface and grouping the corners which define them. Selection keys like A key eases the process of grouping. First select an edge or a few corners which includes the desired corners. Next hold the A key in the keyboard and click on an edge close to the corner which represents the desired sheet. assigning the grouped corners to the current surface. Similarly, making the second ellipsoid current and assigning the respective corners to it. Similarly, assigning the respective corners to all the ellipsoids and planes. Now that all the surfaces are assigned, let's check the validity of the topology. The topology is valid without any singularities. The default density of an edge is 8, but not all the edges are of same length. So modifying the density of the longer edges helps in generating a smooth transition grid. The density of the longer edges are being modified to 16. Starting the gridding process. It can be monitored either from the UI or command terminal. Switching to grid tab and loading the grid. To view the grid cells, the surface grid sheets have to be created using Faces button. Updating the grid after 900 sweeps. The grid points are smoothly positioned as required, stopping the gridding process since the desired grid is obtained. As mentioned before, the generated grid will be used for post-processing to get the final grid. Running EXTCon on the existing grid. EXTCon is a post-processing tool which mirrors and merges the grid together. This is how the resultant grid looks. As you can see, it is merged together into a single grid. This is how the grid looks once it is mirrored on the top. Similarly, the grid is mirrored and merged on the left side also. Post-processing tools such as EXTCon, TRF, and Weld eases the process of grid generation significantly. Please refer the documentation of these tools for more information. Thank you for watching. See you in the next video.